Okay, everybody, let's go ahead and finish up this last example for thermodynamics. Can we do it? Hopefully. And if you have no idea what the name of this is about, go listen to some silly songs. So, what we're going to do this time, we're going to calculate the absolute pressure P1 of the manometer shown in the figure. Where's the figure? There it is. The local atmospheric pressure is 758 millimeters mercury. Remember, that's a unit of pressure because we use a barometer, which is filled with mercury, to measure pressure. So it's the hydrostatic pressure from a column that is 758 millimeters high of mercury. And we're going to take the weight of fluid A, whatever that is, to be 100 kilonewtons per meter cubed. And you can see that fluid B is 8 kilonewtons per meter cubed. Okay, now you can see this is kind of a crazy setup all the way down there. We have some pressure pushing down on one side, we have atmospheric pressure pushing down on the other. What we can see is that pressure 1 must be higher than atmospheric because it is pushing the fluids up. This guy is higher than this guy. Now, how are we going to calculate this? There's just so much going on. There is. There totally is. And it's not that bad. Because the big thing here is that if you see it equal, then it doesn't do anything. Like what you can see right here is that this U, everybody see that? That U doesn't do squat. The reason for that is because it's the same on both sides. This guy right here doesn't do anything. Why? Because it's the same on both sides. Okay? It's the same on both sides. So the only times we really care about something are when we can see a difference. Like right here, there is no other half to this section right here. There is no other half to this section right here. So I can get rid of quite a bit of this. I'm just going to scribble through it. Why? Because I like scribbling. It's fun. Okay. So those are the sections that we care about. And those are the ones that are actually exerting hydrostatic pressure onto my object. Or in this case, hydrostatic pressure against P1. So, if I look at that then, I know that P1 has to be equal to my atmospheric pressure because that guy's pushing down right here. And I have hydrostatic pressure from two fluids, fluid B and fluid A. As a note, fluid A and fluid B have different densities. Gravity should be the same for both of them. The heights are what we have to calculate using the numbers we see in that graph. Okay. Now, another way we can write this to make things a little bit easier on us, because this right here, this is a specific weight. How do I know it's a specific weight? Because it's a weight per unit volume. So I can take it, instead of doing it in terms of density and gravity, I do it in terms of specific weight, because I know that. I don't technically know the density. I could have calculated it, but it's just an extra step then. Okay, now we have to figure out what height A and height B are. So if we look at right here, we see that height A is 0.05, height B is 0.15. Why are they that? Well, hopefully my little diagram here where I did all the scribbles is helping. You'll see is that there's one section of fluid for fluid B that isn't matched. There's one section of fluid for fluid A that isn't matched. And guess what? How much of fluid A isn't matched? 5 centimeters worth. How much of fluid B isn't matched? 15 centimeters. 15.05. The specific weights are given to us by the problem itself. We plug it all in, and we have our answer, which is 107.24 kilopascals. As a note, this is a very helpful conversion right here from millimeters mercury to kilopascals. You don't see millimeters mercury terribly much in this course, but you will see it. So definitely know how to deal with it. You're always going to have to convert to units like kilopascal or PSI at the very, very least. And that's it. So just kind of recapping, when you have this kind of crazy U-shaped manometer, mark off all the sections that are matched, as in like it's a perfect U. So this section right here was a perfect U, this section right here was a perfect U, this section right here was a perfect U. Once you've done that, you know what you don't have to deal with. Those don't do anything because they're equal pressure on both sides, and so it's only the unmatched sections that do anything for your pressure, do anything for your problem, and it makes it a lot simpler to look at. So that'll be it for this time. I think that's everything. So thank you all so very much. See you later. Bye bye.